Yebo, so we were supposed to answer this question. We answered it in class today, and I want to revise it with you guys quickly. It says ship A sails at 30 kilometers per hour north, 48 degrees west, while ship B is sailing at 20 kilometers per hour south, 15 degrees east. To start off, we might as well just draw the original one based on the given information as we see it. So here, let's start. We have 30 kilometers north, 48 degrees towards the west. So north moves upwards. This is how we said we do it. You move upwards, 48 towards the west. The west is this side. This is north, south, and east. So let's go through it again. North, you move upwards, 48 degrees towards the west. And then, yeah. This side we have, this is our A, which is 30 kilometers per hour. This here we have 48 degrees. That is 48. Sharp. It says wildest ship B is sailing 20 kilometers south. So south, 15 degrees east. So south moves in a downward direction, 15 degrees towards the east. 15 degrees towards the east, you just put a curve towards the east there, an angle, and so there. And so this is just the original given information. So we discussed about vectors. We said we always want to represent our vectors where the angles are touching the x-axis. If you'll notice, all of these two angles are touching the y-axis. So if that's the case, you're interested in finding this angle, you're interested in finding this angle. To do that, we already know we have 90 degrees there and here. So we will then say 90 minus your 48, we have 42. This is 42 degrees. 90 minus 15, we have 75. So I have a 75 degrees. Then we can answer the question. 4.9 says draw a neat vector diagram and show clearly the vector representing the velocity of A relative to B. Maybe just so I make certain things clear, the formula VAB equals to VA minus VB. The purpose of this minus is to change the direction for B naturally. So that's why even when you draw the, or rather when we use the second method, when we said VAB equals to VA plus VB, when we use this method in class and we had to redraw our information here, we had to change the direction for VB, the vector diagram, or rather the vector arrow for VB. So 4.1 says draw a neat vector diagram and show clearly the vector representing the velocity of A relative to B. In this case, that kind of trying to say we must draw the line or the vector line for the relative velocity of A as it is related to B. So in such a case as this one, the best way you can answer this question 4.1 is to just draw a parallelogram. Typically 4.2 would easily show you how to draw this relative velocity of A relative to B. The alternative way just to show the vector is by using a parallelogram. So for 4.1, if you're going to be using a parallelogram method, then a small Cartesian plane there. We'll start maybe with 30. We have 30. Let's do this. So we have 30, this is 42 degrees, and this side we have, I'll represent it with a small a, this is going to be 30 kilometers per hour. That's our 30 there. The next part is, yeah, so we have two options. It's either I'll draw my B here or at the far end of this A here. So if I draw it here, I just draw another small Cartesian plane. So in this case, I want B. Now B, the angle for B is 75, and it's for a force which is 20. This is how much? It's 20. So because it's 20, it's less than 30. I'll make sure that my line is not so much, what do we call it, longer than the one for 30. So we're just trying to make sense out of it. So this side I have B, this is B, and this is going to be 20 kilometers per hour. My angle measurement from this reference until there, I can use the one for 75 degrees, for 75 degrees. And then from this information here, now I could easily just draw a line literally from the starting point until the end point at this point here. The alternative way is to just draw a parallelogram, as we said. So you would then have to redraw this 75 again at the starting point, just around there. Hopefully this line should be almost equal to the other one. So angles wise, we're just using approximation. 75 would have to easily have a larger angle. It wouldn't be closer to the x-axis, it would be further. 42 is the one which is closer, as you see it down here. So thus I pushed it a bit up. We still have another 75 again from this point until there. Until there. You have a 75. So now remember, this line is for B. Then you could complete your parallelogram. You still know this, the opposite side, the other side which is parallel to this one is still what? A. We then said our relative velocity would be the straight line within this very parallelogram, which is that line there. So your vector then, your relative velocity vector, you should know this in the middle here is going to be your relative velocity, which is the same as c. Yeah, so 4.2, it then says calculate the velocity of A relative to B in magnitude and direction. So us, we are looking for C. Before we find C, we need to be aware we have all of these sides for A, B, and C. We need to have certain angles. So considering that the side for B is here, it's the opposite to the angle which should be inside here. In our case, it is B. The one for A, this side A is going to be around there, the angle for A, and then C is going to be around there. So yeah, because it's the opposite of C, this side is facing C, this side is faced down there, A is facing up there, something like that. Let's revise. So the side for A there. Sharp. So to find our relative velocity, we're using C. We need to find the angle for C. To find the angle for C, what we then do is this. We have a couple of options. Part of our options are like this. So remember, around here, just around here, this 42 degrees, we still have the same angle there. We have a 42 degrees. And then for B, according to B, the angle which was on the y-axis, we had a 15. Remember, this side is for B, and we had this 15 here. And then here I have a 90 degrees. So all I can do is say 15 plus 90 plus 42. This 42 is the same as this one down here. This 15 is the one which we had from the beginning. So we have 15 plus 90 plus 42. If that's the case, we're going to have 15 plus 90 plus 42. It gives us 147. So the next time I need to find this angle, or I have to represent it, I should know my C value is 147. So if that's the case, inside here, I can represent my C. My C in here is going to be 147 degrees. There, 147 degrees. And then from here, my battery's about to die. Alright, there's life. From here, we can apply maths. So applying maths, we are looking for the side for C. To find the side for C, we are saying C squared equals to A squared plus B squared minus 2AB cos C. Alternatively, you can just apply the square root of this whole side. Yeah, then we substitute. So to substitute, my A, so A is this side for 30. So this is going to be 30 squared plus 20 squared minus 2 times 30 times 20 times cos. The angle for C is the one we were calculating now, which is 147, close bracket. Then here we will have the square root of 30 squared plus 20 plus 20 squared minus 2 times 30 times 20 times cos 147. And we got 48,025. We got a 48,025. This is measured in kilometers per hour. Question said we should also find the direction as well. To find our direction, so to find the angle, we'll consider the sides again. Like I was saying, we have the side for C and the angle for C. We are looking for the angle for B and this one here. So if that's the case, we'll be saying B over sine B equals to C over sine C. We are looking for the angle for B, so you'll cross multiply. You will have B times sine C equals to C times sine B. You'll divide both sides by C. then your sine B will be equals to B sine C over C, where you apply the shift of whatever value we have or values we have. Bear in mind this is our angle. Sure, so when you substitute we have sine. Let's check how much do we have for B. So B we had a 20. So we have a 20 sine times sine. The angle we found for C was 147. All over we got, how much was this? 48. This is 48, 025. And then you type your calculator, shift sine. This is 20 times sine 147 over 48, 025. We have 13,11. 13,11 degrees. So in science we typically use 3 decimals. Because of this 6 it affects the 9, we then move on to the second decimal. So yeah, we said we want to find B because we want to add the angle for 42 plus B. So in this case here you're saying theta equals to 42 plus 13,11, you'll get something like 55,11 degrees. So yeah, this is the alternative method. 4.2, just because they required you to draw this vector diagram doesn't necessarily force you to apply this equations. You can still go through the normal ones where you're still saying VAB equals to your VA minus VB. If you're not using this one, you're using the other formulas for VAB equals to VA plus VB. You remember that when you use this method here, you would need to change the direction for B, as I did up here. So do remember that if you're using the first one, then you're using your vector diagram as it was. Otherwise, hola. I just remembered when they refer to the direction and you have to find your angle, that considering that it's from there, from this side going up, if I were to just draw a simple Cartesian plane, and this would be my relative velocity in this direction, and I would have to label this in regards to northwest, south. This is northwest, south, and east. So I have a 55,11 degrees. In this case, referring to the principle we were using earlier on, if I were to write the final answer for the resultant, then my resultant is going to be 48,025 kilometers per hour. Remember, we added these angles here. So direction wise, I would start and say on the horizontal, we have west. So it's going to be west 55,1, 1 degrees, and it's still moving towards the north. So yeah, this is how you would do the whole thing. Yeah, we'll do more questions in class.